Alright. Maintenance instruction on electrical motive turbocharged overhaul procedure for 645 series engine. This for maintenance instruction 275 revision C. We're on class 3 rebuilds. Rebuilds, Class 3. Stand rotor preparation, Class 3 rebuild used on all turbos except high capacity 1 required to provide support, protect the rotating assembly during various qualification dimensional checks. With a back plate installed with the sun geared side shown in support, provided with the ball bearing used in the heat damp washer squareness check. The plate removed with the spline area can be used to secure the rotating assembly clamp in the sun gear. Centers, rotors, inspection, Class 3 rebuild used on all turbos except high capacity 1 required provides a safety stand with the rotor inspection. Balance rotor, Class 1 through Class 3 rebuild used on all turbos required provides a means for correcting impact and balance for the rotating assembly after work. The qualified used assembly for reused models are presently in use. The GP500 and the HBS 350 GP with superseded with the GP500 with the balance of the rotating assembly pulley must be used in the machine. Stand up the operating procedure. Both these models include at the end of the section no illustration. Pulley driver, Class 3 billboard used on turbo, used in balancer, provide with the proper RPM balancing rotating assembly. The scale and blade weight, Class 3 billboard used on all turbines required balance, replacing the turbine blades. Each replacement blade must be within plus or minus of a half a gram or old blade of the scale graduated with 1/10 of a gram increments. Rebuild Class 4. The reamer, clutch driver, pinholes. Reamers are driven with the pinholes in clutch dowling assembly standard at 10.079 or 10.084 millimeters. The reamers have straight 7.894 to 7.904 millimeter shank. The rebuild Class 5 lifter turbo dowling assembly. Class 5 rebuild used on all turbos. Use the clamp to evenly position the main housing assembly for the insertion and removal of the dowel fixture, and can also be used with the turbine bearing support, compressor bearing support mated with the main housing. The two oblong plates attached with the 654.1 millimeter chains are 25 and 3/4 of an inch. Chains have crossbars. T-shaped lifter holder bolted to the main housing lifting pad. The clamp is mounted on the outside of the oil drain hole in the bottom of the main housing horseshoe with lifting hole of the clamp position over the center line of the main housing at 387.4 millimeters or 15 1/4 chain inches. The front of the T-shaped lifter shall be attached to the clamp. The dowling assembly can now be raised, lowered into the dowling fixture, maintaining a horizontal attitude. Alright, your lifter turbo dowling assembly. Class 5 rebuild used on all turbos used in slinging a clamp at the reverse position of the main housing after it has been mated after the turbine bearing support, the compressor bearing support, enabling the alignment dowling, ideal gear support. Both the two plate lifters of the main housing lifting pad with the chain to the outside with the hoist suspended with the dowling assembly. Mount the sling and the clamp. The two center bolt holes in the bottom of the main housing. Attach the sling clamp to the second hoist position to the direct lifting force of the direction of the rollover rail. Raise the second hoisting to the dowling assembly in the position desired. Simultaneously lower both hoists. The clamp turbo dwelling assembly lift. Class 5 rebuilds used only on turbos when required. Used with a lifter. The description add the instruction set up with the set description under the turbo dowling assembly lifter. And also your sling clamp turbo dowling rollover. Class 5 rebuild used on all turbos required. Used in a rollover lift for description instruction for the C description under the turbo dwelling assembly rollover lifter. Your reamer turbine bearing support. Class 5 rebuilds used on all turbos. Turbos for 2 each. Reamers are accommodated oversized dowels with interface for the fit between the main housing and the turbo bearing support. Standard size is 12.6.87 millimeters plus or minus 10 thousandths or 8 10 thousandths. Reamers have number 2 Morse taper. These reamers are also used for the oversized dowel holes with the 2 extra holes with the idle gear support with the main turbocharged ratchet clutches. Reamer compressor bearing. The Class 5 rebuild used on Turbo 2 for each of the required. Reamers are used to accommodate oversized dowels interface with the fit between the main housing and compressor bearing support between the compressor bearing support and the compressor scroll. The standard size of 12.689 millimeters or plus or minus at 8 thousandths of an inch, or the reamer have no number 2 Morse taper. Alright, your reamer idler gear support. Class 5 rebuild used on all turbos. Reamers are accommodated oversized dowels that interferes between the main housing. Idler gear support standard size is 12.87 millimeters, 12.827 millimeters, or plus or minus a negative 8 and 10 thousandths of an inch. Reamers have no Morse taper. The reamer carrier bearing. Class 5 rebuild used on all Turbo 2 each required reamers accommodate the oversized dowels interface for the fit between the carrier bearing support, idler gear support, standard size, section 13.528 millimeters or 8 thousandths of an inch, or reamers have 11.11 millimeter shank. Alright, your aligner and turbo dwelling. Class 5 rebuild used on all turbos. Required fixtures. The alignment of the turbo doweling assembly can be used with the complete and partial alignment. The first illustration shown with the alignment of the figure. Show the second show the tram gauge for the aligning of the gear for support with the main housing structure. Instructions. See section 3 of the maintenance instruction. Alright, your reamer carrier bearing support standards. Reamers are standard sized dowels that interference fit between the carrier's bearing support, idler gear support. Reamers of 11.11 millimeter shank. Rebuild class 6. Fixture turbine scroll machine. Used on all turbos, lines the holes of the turbine inlet scroll with the machine of the very vertical lath after the welded repair. The end milled turbine scroll key used on all turbos 6. End milled turbine scroll key finish. Semi and finish and finish. Spreads special ended materials machining inlet scroll keyways used on a mill holder. Also, your tester hydrostatic class 6 rebuild use all turbos require primarily hydrostatic testing, oil, air, and compressor bearing supporter after rework of the severe failure to blank off the support, and blank can be made with the user's adaptive fixtures over the housing. The holder and mill. Class 6 rebuild used on all turbos, special holder end mills. This fixture has a number 50 milling machine taper. Your fixture shroud ID machine used on all ID machining. Class 6 rebuild used on all turbos, holding the fixture machine with the shroud ID used in both coated and non-coated shrouds used with the vertical lath that can accommodate the 450.9 millimeter OD. Note that ensure that hold down the arrangement of the lath table does not distort the shroud. The fixture compressing bearing supporting machine. Class 6 rebuild used on all turbos. Properly positioned compressor bearing support bores and thrust face. Inserting machine used in the guide pins and handler. Inserting machine 16E and EB and 20 and E and EB compressor bearing support. Vertical lath must be able to accommodate the fixtures of 1,422 millimeter or 56 inches diameter. Alright, your guide pin. A Class 6 rebuild used in the 16E and EB and 20E and EB turbos 2 required. Use the compressor bearing support machining the fixture to guide the aligning insertion during the installation. Testing compressor bearing support repair. Class 6 rebuild used on all turbos required. Using the hydrostatic tester, water tester, compressor bearing support. After the repair of severe failure of the turbocharger, the 2 round pieces seal the compressor journal bearing area. The rectangular pieces blank in the plug hole. The handler compressor bearing support inserter. Class 6 rebuild used in the 16E and EB and 20E and B turbos. Required for the compressor bearing support machine fixture guide pins installed with the chilled insert with the support. The device is located with the oil drain hole. Drill fixture idler gear support conversion to higher capacity. Class 6 used in the 16E and EB, 20 and EB turbos capacity 1 required. These used with the guided machine idler gear support conversion, the high capacity gear train turbo, the fixture located with the idler shove shaft, pilot with a bolt hole directly below the drain hole with the support, performing the few following steps. Drill a second oil spitter hole 1.19 millimeter diameters or in 15.88 millimeters deep. But with the large 22.225 millimeters OD brushing, remove so it does not obstruct drilling guide with additional bolt hole, drill bolt hole in 10.716 millimeter diameter idle gear support at 30.15 millimeters. Install an 18.256 millimeter ID brushing and locking with a locking bolt drill at 18.256 diameter hole through the support. Replace the 18.265 ID bushing with the 19.055 ID bushing. Remain the 19.063 millimeters by 0 plus or minus 0.25 thousandths of an inch through the support. Remove the fixture tab with the new bolt with the 1/2 inch UNC3B threaded through the support. And the main housing does not have a thread hole except the bolt that goes through the idler stub shaft. Pilot proceed to the next tools listing. Special bushing 10.72 millimeters diameter. Class 3 6 rebuild using converting 16 E and B and 20 E and EB turbos at high capacity required. A guide drilling hole into the main housing except for the bolt through the idler subshaft. Pilot with the high capacity turbos down with the bolt on the idle gear support of the main housing. Position the two pieces in the idle gear support facing up. Install the bushing with the idle gear support subshaft. Pilot drill 10.72 millimeters diameter hole and 34.93 millimeters deep in the main housing. Remove the bushing and the tap into the hole with the 1/2 UNC3B threaded 25.4 millimeters deep. Alright, your end milling turbine scroll key, class 6 rebuild used on all turbos, special end of the mill used for the rough cuts, and the machine inlet scroll keyways used on the end with the miller holder, gauge, flange, thickness, turbine scroll, class 6 rebuild, qualifies inlet scrolls of 3.23 millimeters, flange thickness with the after machine setting on the master gauge, master turbine scroll, flange thickness, class 6 rebuild used on all turbines, master setting of the gauge, gauge flange diameter turbine scroll class 6 rebuild used on all turbos required. Qualifies the inlet scroll of 387.81 millimeters flange diameter after machining set on master gauge. Master turbine scroll flange diameter class 6 rebuild used on all turbos. Master setting gauge G57324. Alright, your setup procedure for the GP500 and HBS350 GP. Both visually inspect for the obvious damage for the ore imbalance. Apply with a strip of the tape around the OD blades. Both set in place for the machine. Mark with the place of the impeller turbine with the numbers used in the strobe light with the turbine on the left and the impeller on the right. Both fit the drive belt over the part of the test and constant speed. Adjust the belts and part of the necessary bolt. They are marked with the type of the plate, marked with tape black to the sun gear, and focus the electrical photocell on it from the distance of 25.4 millimeters or 1 inch. Both measure 2.9 grams of the wax height and set aside. GP500 place the filter dials and plane separation dials to 0, calibration dials to 0, and compensator to the out position. 6A, the HBS350GB, place filter dial, both planes, separation dial 0, both calibration dials to 10, scale with the switch to the 10 times 10 times 5, both plus or minus switches plus, compensators out of position. See the switch back in the machine to 1 times or 1 times 1 to the 10. Both apply the wax heat impeller with a 152.4 millimeter radius. Ensure the imbalance proper filter adjustment. Remove the weight after the filters are set with the release of the floating cradle lock. The GP500 rotate the switch left and right. Switch to the far right position. Adjust the right and left filter pots to get maximum defect to the peak of the amount meter. The HBS 350 GP rotate the approximately 654 RPMs. Hold down the right push button and adjust the filter and get a maximum deflection peak of the amount meter. If the amount goes over the scale, the peak is obtained, bring it into the scale right calibration dial. Continue the adjusted filters on one filter on the HBS 350 GPM, or for the maximum deflection peak of the meter, return the right calibration pot to preset position after filters are set. 9. The GP50. Turn the compensator switch to the 5 with the rotate with the switch left to right. Switch slightly with the right, activating over the 0 to 50 scale on the amount of the meter. Adjust the right null pots to the needle amount of the meter towards 0. When the needle falls below 10, move the left or the right switch to the far 110 scale, continuing adjusting right null until the amount of the meter is at 0. 2 to 3 lines may be best possible. Repeat the above procedure for the left plane. The HBS350 GP, do not, turn the compensator switch to the fine, rotate the part, leave the scale within at 5 times the push right button, adjust the right compensator draws, bring the needle of the amount meter towards 0. If the meter does not respond, change it, switch back to the machine to 10 times, or 1 to the 10th, and repeat above the procedure left playing. GP500, add the 2.9 gram weight of the turbine wheel at 114.3 millimeter radius of the rotating part. Switch the right and left switch to the right, far right position using the right plane. And the separation pot, bring the meter needle the closest to the 0 possible and rotate the pot through the entire range. Ensure the lowest possible reading is obtained. HBS350 GP, add the 2.9 gram weight in the turbine wheel at 114.3 millimeters radius rotating part left to the right of the push button, and using the right plane separation pot, bring the meter needle into the closest 0 possible. Rotate the pot in either entire of the range to ensure that the lowest part of the possible reading is obtained. 11. GP500, remove the 2.9 gram weight from the turbine, place it on its unmarked propeller at 152.4 millimeter radius. Make a note of the number angle as it is. Rotate the part and switch left to right from left position using the left plane separation pot, bringing the meter needle as close to 0 as possible, rotating the pot through the entire range to ensure the lowest possible reading is obtained. The HGS350 GP, remove the 2.9 gram weight for the turbine plate for the impeller at the 152.4 millimeters or 6-inch radius, making a note of what the number angle is at. Rotate the part and push the left button using left plane separation. Bring the meter needle to the closest 0 as possible. Rotate the pot through the entire range to ensure that the lowest possible reading is obtained. Alright, GP500 within 2.9 grams will still on the impeller with the part of the rotating switch to the left of the switch for the far right position, just to the right of the calibration pot. So on the scale reading is observed the meter and the number of the wave that was placed on the set as seemed under the strobe light. Carefully touch up filter dials to summon the number directly light strobe with the horizontal plane. Turn the calibration opposite with the 50 to it and adjust the needle until the meter reads 6 inches or the angle of 180 degrees weight of the light on the strobe. The HBS 350 GP with the weight of the 2.9 gram weight is still on the impeller with the particle rotate, push the right button. Carefully touch up the filter dial stem, the normal directly light strobe in the horizontal plane. Adjust the right calibration pot so the meter needle is on the scale. Put the right plus minus switch in the position with the heads and the number angle, and have the weight of the understrobe. Switch to the right plus minus switch to the opposite position. Adjust the calibration pot and filter so that the meter reads 6 inches and the meter does not respond. Change the switch from back to the machine to 10 times, and the angle of 180 degrees from the weight should be now visible. 13. Both. Turn the compensator to out and remove all the weights. GP14, GP500, remove the 2.9 gram weight from the impeller, place it on in the turbine at 114.3 millimeter radius, making note of the number of the impeller. Rotate the part. Switch the left to right, switch to the far left position, adjust the left calibration point so far, and the number 180 degrees weight is observed under the strobe, and move the meter to read 114.3 millimeters. 14A, the HBS GP and 350 GP, remove the 2.9 gram weight impeller placed on the turbine with 114 out 3 millimeter, making note that the number of the impeller. Rotate the part of the left button, push button, switch to left, push plus minus switch the position with the number of the 180 degrees from the weight is observed under the strobe. Adjust the left calibration pot filter so the meter reads 114.3 millimeters. 15. Both. Rotate part of the reading and the balance in each of the plane. Both obtain the weight needed to counteract the imbalance and its proper plane with the position of the angle where the wear is needed as indicated with the strobe light. Both. Clear. Check the balance in each of the planes. So again, both. Repeat the 16 17 until the balance is in acceptable range in 17.0 milligrams or 18.00 milligrams or a tenth of an ounce of an inch to 25 thousandths of an ounce of an inch. Both. Remove the weight remove the appropriate amount of the material from the area 180 degrees from the weight is added. Both. Recheck the balancing of this part. And that concludes the maintenance instruction for the turbo overhaul procedure 645 series engine turbocharger electromotive division 645 series engines.